Hello guys, welcome back to my channel. I'm here with another exciting project, dog cat classification using CNN. So in this project, so first of all I split the data into train and test, and then I will use ANN, normalize the images, and then use ANN. The reason is I want to compare the performance between ANN and CNN, and saying why we are using CNN for images. So here, so I just quickly show you the ANN. So we have 150 by 150 images, and these trees because they are in RGB, and then I use a flatten layer and one dense layer, and this is actually full connector layer, and the output is 2 because we want to say if it is actually dog or cat. So let's see the performance. I used 10 epochs. Okay, as you see, in 10 epochs I got something around 63%, and just let's evaluate the model by using test data. Yeah, that's close to 60%. And now I want to use CNN. So in the CNN I use first of all I use convolutional, then I use max pooling. I will tell you what is max pooling, and then another layer, and then flatten and ANN actually. So this is the description of the model. Again, I use 10 epochs. I just want to compare the performance between this one and ANN. And there is really interesting point I want to mention. So here we have 10 epochs, but we got much more accuracy in compared with ANN. But there is another thing that we will another problem that we will face, and just if you wait a little bit I will tell you. Okay, in second epochs we got around 68%. That's much more better than ANN. So 75, 77, 80, and by the way I'm using GPU for this project because it's taking a lot of time, and I want to do that much faster. and actually because I reshape images to 150 by 150, that will take less time. See, in epoch 9 we got something around 90%. Okay, 94% in last epoch. So I will evaluate the model. So I got something around 75% for test images. So we can see here we face actually overfitting. Why? Because here we got something around 95%, but in test data we got something around 75%. So clearly we face overfitting. So there are several ways that we can actually overcome overfitting, like increasing training data and data augmentation, and also there are some more actually approaches that we can use. So in the first one, so I'm use the dropout layer. So I already talked about the dropout layer in my AN project. If you haven't seen that, please go ahead and watch that. So here I use actually to dropout, and it means I just drop out 1/10 actually all the neurons. Okay, and so let's see the result. So again I use 10 epochs. Actually this one will be a little bit faster because we use the dropout and we delete some neurons. So 48, 50. In the third epochs we got something around 50. Guys, that's like try and error, and I just want to find the best method that we can overcome overfitting. Okay, this is one of the ways. So 69, 69, 69. Okay, the performance for this one is not good that much because we got something around 50% accuracy. That's not good. But I just want to show you different ways that we can do that. Okay, in last epochs we got actually around 70%, 50%, sorry. So that's not good, but let's see what else we can do. I will evaluate the model. So same thing, actually around 50%. That's not good. So here I'm gonna use data augmentation. So let's talk about the presentation. In A and N we use flattened images, and we have, in my project I have only one fully connected layer, and one output layer. Definitely if you use more fully connected layers, you will get much better accuracy. So this is the ANN, and I had one hidden layer or fully connected, and I just had actually binary classification because I want to understand if the image is cat or dog. And I'm gonna tell you why ANN is not useful in this case. So because so in first layer we got something around 67,000 okay neurons. So and if we have something like one hidden layer with 5,000 neurons, that's like a lot of computation. So we need something like 350 million neurons. That's like too much computation. And guys, please consider something else, because I just actually resize the images to 150 by 150, but consider if we have something more than that, that will be much more than this number. And here, so I'm gonna talk about the CNN. So actually in CNN we don't need that much computation, and we will understand for example we can extract a lot of features, and actually CNN does it by itself. You don't need to be worried about that. So for example, one of the features here is ears, eyes and nose here, and I will tell you how CNN works for us. So assume this is my image. I just made it short because I want you guys understand the procedure. So here I have the filter. This is the filter, and this is the filter is something like the feature that we have, like eyes, nose and whatever. And here actually my filter will go over the image, and it will make this one. This one is, we call it feature map. So I just, for the first one, I will tell you how we can do it. So here 10 times by 10 plus 9 times by 8 plus 5 times 7, and here we have 9 times 8 and plus 6 times 6 and 16 times 10 plus 6 times 5, 10 times 16 and 9 times 9. And actually we will divide that by 9, because we have 9. Actually it's something like averaging. And so I want to tell you something about CNN. It doesn't matter where features are in your image, so you will detect it automatically. You don't need to be worried about that. Okay, for example, about the eyes. Here eyes, the cat eyes is right here, but in this one the location is different. And why CNN? So because you actually CNN is more useful for images, because so they can automatically actually find the features, and in compared to ANN that much faster, and you can get much better accuracy. So I already show you in my code. So, and this is more actually detail about that. So let me tell you something here. So we have, this is the original image, okay, and this is one of our filter, or one of the feature that we want to use. And here, so it will go over the actually image and make the feature map. The feature map is actually this is the original one, but after applying the filters on it, okay. And then we have ReLU. ReLU is look at this one, and we have some minus numbers. So when you apply the ReLU, that will get only positive actual numbers. So, and we'll put 0 in place of minus values, okay. And after max pooling, what is max pooling? So consider 2x2 filter. So in the filter we will get the maximum number. Here, for example, we have 84, 38, 12 and 43, and here the maximum is 84. We have other actually average pooling and other poolings that we can use, but max pooling is the most famous one. So for here we have 38, 45, 43 and 25, and here is the maximum is 45, okay. And same thing for the rest of the image. And there is one point I want to mention, and actually when you using max pooling, you reducing the image size, and because of that the image size is will be much less, and you don't need to be worried about the computation. And this is the benefit of max pooling, actually reducing the computation, as I told you. Actually this is one of the way that you can overcome overfitting. And actually here you will get in the main feature, alright. And so this is about the CNN. In the first layer of CNN, actually we have multiple layers of convolution and ReLU and pooling, and in the rest we have regular ANN, because we want to do classification task. And yeah, that's it. Okay guys, let's back to the code. And for augmentation, actually what we can do is actually when we don't have enough data, or when we actually want to increase the size of the data, or when we want to actually overcome the what you call it, overcome the I forgot the name, overfitting. Okay, so I will check this one. This is the model. So there are several ways that you can actually use for actually augmentation, but one of the ways is like this. You can actually define your what you call it, define your data, and define your actually the way that you want to treat your data. So for example, here I have I use the random flip and random zoom, and actually random rotation. So that will do that for me. And after running this, you will see the difference soon. Okay, and again I use 10 epochs because I want to compare them, compare the result. That will take a little bit time, and then we will have the result. Guys, look at this. In first epoch we got pretty good accuracy in compare with A and N. 57, 66, 69, 71, 72, 72, 73, 75, 76. Okay, and I just want to see if we have overfitting problem anymore or not. Okay, actually that sounds good because we got 77, and that's really close to what we got in our train data. Okay guys, thank you so much. I will share you this actually notebook and the link to dataset. Thank you so much, and see you in next video. Bye.